Welcome to Outbreak Brief, the podcast that takes you inside the world's most dangerous infections.
Mm-hmm.
Today, we are profiling a pathogen that is, it's the ultimate master of disguise. It's this stealthy, invisible invader that just hides in plain sight, waiting for the perfect moment to strike.
Right.
And right now, as you listen to this, there is an 83% chance that you have a highly complex 200-page genetic blueprint of a virus sleeping deep inside your bone marrow.
It's wild to think about.
It really is. It's a lifelong passenger. You can't cure it. You can't evict it.
Wow.
So today we are doing a deep dive into cytomegalovirus, or CMV.
Yeah, and when people think of dangerous outbreaks, the mind usually jumps to like sirens, hazmat suits, rapidly spreading hemorrhagic fevers.
Exactly, like Ebola or COVID-19.
Right. But CMV operates entirely under the radar. I mean, it is a slow, silent, and just incredibly patient threat that has, it's basically woven itself into the very fabric of human biology.
And the numbers on this are just staggering. In the United States, nearly 1 in 3 children is infected by age 5.
Yeah.
And globally, like we mentioned, 83% of the human population carries this virus. Over half of all adults have it by the time they hit 40. And yet, if you ask the average person on the street about CMV, they have probably never even heard of it.
Which, honestly, is truly the greatest trick this virus ever pulled. Most people have absolutely no idea they're infected.
Right.
Once CMV enters your body, it establishes this lifelong latency. It acts as a silent, dormant passenger in your cells for the rest of your life. It rarely raises a single alarm, unless the conditions are perfectly in its favor.
So let's unpack this, because to understand how something can infect billions of people without causing a global panic, we really have to look at the anatomy of this invisible invader.
Exactly.
What exactly are we dealing with here? Let's pull up the villain profile.
Sure. So CMV is formerly known as Human Herpesvirus 5. And as the name implies, it is part of the Herpesviridae family. Structurally, it's a double-stranded DNA virus, and it's encased in a lipid envelope. But what makes CMV uniquely dangerous, and frankly just a marvel of evolutionary biology, is its sheer size and complexity.
Wait, size? Like, how big are we talking?
Well, genetically speaking, it has the largest genome of any human virus. We are looking at a genome measuring about 230 kilobases.
Let me stop you there for a second. Translating kilobases for the listener, we are talking about hundreds of thousands of genetic letters, right?
Yes, exactly. 230,000 base pairs of DNA. And it contains roughly 200 protein-encoding genes.
Wow.
To put that in perspective, right, the virus that causes COVID-19 gets by with about 30,000 base pairs and roughly a dozen genes.
Just a dozen.
Yeah, a dozen. CMV has 200. It is this massive, sprawling genetic code.
So it's basically a criminal mastermind with a ridiculously detailed 200-page blueprint for a fortress.
That's a great way to put it.
But, that raises a massive red flag for me. Usually a big, complex pathogen is clumsy, right? It's easy for our white blood cells to spot. If it is so massive and carries all this equipment, how does it manage to stay entirely off our immune system's radar?
Well, the answer to that lies deep in human history. To understand this virus, you have to realize it has been locked in an evolutionary arms race with the human immune system for millions of years.
Millions.
Millions. Herpesviruses are ancient. They've evolved alongside us. And because of that deep shared history, CMV has developed a highly specialized survival mechanism, which we call transcriptional silencing.
Transcriptional silencing. Okay, let's get into the mechanics of that. What is it actually doing inside the body?
So when CMV first infects you, your immune system mounts a defense, like it normally would, and clears the active replicating virus from your bloodstream.
Right, the standard immune response.
Exactly. But the virus has a backup plan. It finds its way into your myeloid cells.
And myeloid cells being, what exactly are those?
They're the precursor cells that live deep inside your bone marrow. They eventually develop into various types of blood cells, including monocytes.
Okay, got it.
So once the virus gets inside these bone marrow cells, it simply turns off its own replication.
Yeah.
It just powers down the factory.
It just shuts down.
Totally. It stops producing viral proteins entirely.
It just goes dark. So, transcriptional silencing is essentially like a hostile submarine slipping past our naval defenses, dropping to the ocean floor, and just completely cutting its engines to avoid sonar.
Yes.
It's entirely invisible until it decides to fire.
That is a perfect way to visualize it.
Yeah.
Because it is producing absolutely no proteins. There's no biological exhaust, so to speak, for your immune system to detect.
Wow.
It literally plays dead, sleeping quietly in the very tissues that produce our immune cells, just waiting until the host's defenses drop.
Which is deeply unsettling, honestly. I mean, it's hiding in the exact factory that makes our immune system.
It's brilliant in a terrifying way.
Yeah. But if it's at the bottom of the ocean, right, completely dormant in our bone marrow, how does a sleeping virus manage to jump host to host and infect 83% of the planet?
Right. Good question.
Like, it has to wake up at some point to spread, doesn't it?
It does. Periodically, as those monocytes mature and travel through the bloodstream to different tissues in the body, the virus will quietly reactivate.
Where does it reactivate?
Usually in localized areas like mucosal tissues.
Mm-hmm.
And from there, it relies on the exchange of bodily fluids to spread.
We're talking saliva, things like that.
Exactly. Saliva, tears, blood, semen, breast milk, and urine. It can also be transmitted clinically through solid organ transplants and hematopoietic stem cell transplants.
Right.
But in the general public, the primary transmission routes are incredibly mundane.
And this brings us to one of the most surprising and honestly terrifying vectors for this virus, because the places we associate with the utmost safety are actually ground zero.
Yes, we are talking about young children,
Yep.
daycares,
Yep.
nurseries. When a young child gets infected with CMV, say, a perfectly healthy-looking toddler, they don't just clear the virus and move on.
No.
No, their developing immune systems allow them to actively shed the virus in their saliva and urine for months, sometimes even years, after the initial infection.
Years. Wow. So if you're a parent listening to this, or really anyone who spends time around young kids, just think about how often you engage in behaviors that would transmit this.
Oh, constantly.
A toddler hands you a wet toy, or, you finish their half-eaten cracker, or you give them a kiss on the cheek.
Right.
The virus basically exploits our most fundamental social and caregiving behaviors.
Exactly. And because the child shedding the virus usually has no symptoms whatsoever, there is no warning label.
You look perfectly fine.
Right. And this mundane transmission is why seroprevalence, meaning the percentage of people carrying antibodies against CMV, is so universally high.
Right.
It ranges from 24 to 100% globally.
Right.
And in places like Central America, it easily reaches 90% of the population.
So the vast majority of us get it. And for most of us, the submarine just drops to the ocean floor and stays there.
Usually, yes.
But who is the victim when this virus actually decides to power up its engines and attack? Who is most at risk?
There are two main populations that face the absolute worst outcomes.
Okay.
The first is the unborn, which results in congenital CMV. If a pregnant woman contracts a primary CMV infection, or if her latent virus reactivates, it can cross the placenta and infect the developing fetus.
And the second group?
The second highly vulnerable group includes the immunocompromised.
Right, meaning their immune system is weakened.
Exactly. This means patients with advanced HIV or AIDS, specifically those with CD4 T-cell counts under 50,
Great.
and transplant recipients.
Let's dive into that transplant scenario, because the medical reality here is just chilling.
It really is.
There is a specific hospital situation called the D-positive R-negative mismatch. Walk us through why that is such a nightmare scenario.
Okay, so imagine a patient who desperately needs a new kidney. This recipient is CMV negative. They are one of the few who have never encountered the virus in their life.
Okay.
The donor, however, is CMV positive, meaning the dormant virus is currently sleeping inside the tissue of the donated kidney.
The submarine is in the organ.
Exactly. This is the D-positive R-negative mismatch. Donor positive, recipient negative. Now, to ensure the recipient's body doesn't reject the new organ, doctors have to administer heavy immunosuppressant drugs.
Oh, wow. So you are handing them an organ loaded with a sleeping pathogen and simultaneously turning off the only defense system that could stop it.
It is a perfect storm.
Mm-hmm.
The virus senses the complete lack of immune patrols. It awakens from its transcriptional silencing and begins rapid replication.
Because there's nothing to stop it.
Right. Without cytotoxic T cells to keep it in check, the virus disseminates straight into the bloodstream, a state called CMV anemia, and it begins invading the patient's organs.
So if the immune system is crashed and this massive virus wakes up, what does that tissue invasion actually look like?
It presents in a truly Jekyll and Hyde manner.
How so?
Well, in a healthy individual, a primary CMV infection might cause no symptoms at all, or maybe just a mild mononucleosis like flu. You might have a fever, some fatigue, maybe swollen glands.
You just assume it was a bad cold.
Exactly.
Yeah.
But in a transplant or advanced HIV patient, the virus causes tissue-invasive end organ disease. And the mechanism of how it destroys tissue is brutal.
What is it doing to the cells?
The virus hijacks the cell's machinery to replicate until the cell literally swells to massive proportions and dies, causing widespread tissue necrosis, which is tissue death.
And it doesn't just target one specific area, does it?
Not at all. In the gastrointestinal tract, it causes severe CMV esophagitis. The virus creates deep cavitating ulcers in the esophagus, causing agonizing pain every time the patient swallows.
Oh, that sounds awful.
It is. Moving lower into the gut, it causes severe colitis, leading to abdominal pain, bloody diarrhea, and even bowel perforation. And it can attack the lungs, causing pneumonitis.
Let's break down pneumonitis for a second. How is the virus actually suffocating the patient there?
So the virus attacks the pulmonary interstitium, which is the delicate lace-like scaffolding that surrounds the air sacs in your lungs.
Okay.
As the virus destroys these cells, inflammatory fluid fills that scaffolding. The barrier between the air in your lungs and your bloodstream becomes thick and swollen.
So it's physically blocking the oxygen.
Yes, it physically blocks oxygen from crossing over. The patient experiences dangerous drops in oxygen and can rapidly go into respiratory failure.
And then there's the eye.
Yes, CMV retinitis.
Yeah.
The virus infects the retina at the back of the eye, causing painless, creeping vision loss. Painless. It leaves behind areas of hemorrhage and retinal necrosis. It essentially eats away the visual tissue, leading to irreversible blindness if not stopped immediately.
When pathologists look at this destruction under a microscope, trying to diagnose what is happening, this virus leaves behind a very specific, almost haunting signature, doesn't it?
It does. We call it the classic owl's eye inclusion.
Owl's eye.
Yeah. Because the virus carries such a massive genome, it needs huge amounts of cellular resources to replicate.
Right, the 200-page blueprint.
Exactly. So when CMV infects a cell, it causes the cell to become massive and swollen. This state is called cytomegaly. Inside the nucleus of these giant hijacked cells, pathologists see large, dark, basophilic inclusions.
And a basophilic inclusion is what? Just a massive, dark staining clump of viral material?
Correct. It is the active viral factory. Under the microscope, this dark clump is surrounded by a clear halo, making it look exactly like the eye of an owl staring back at the pathologist.
That is incredibly eerie.
It's highly specific for CMV.
The blueprint is so big, it literally leaves a visible thumbprint on the cell.
Basically, yes.
But we also have to talk about congenital CMV, the danger to the unborn. You mentioned earlier that it can cross the placenta. 1 in 200 babies are born with this. What is the physical toll on them?
About 10% of babies born with congenital CMV will have devastating symptoms right at birth.
10%?
Yes. The virus attacks the developing neurological system. This can lead to microcephaly, which is an abnormally small head and brain. They can suffer from severe jaundice, an enlarged liver and spleen, and seizures.
That's heartbreaking.
It is. But for the babies who appear perfectly healthy at birth, there's often a hidden ticking clock.
The hearing loss. And this isn't just an anatomical defect they're born with, right? Like, this is an active, progressive process. How is the virus causing this?
Right. Hearing loss is the most common long-term health problem for these babies. A child can be born entirely asymptomatic and pass their newborn hearing screening with flying colors.
So the parents think everything is fine.
Exactly. But the virus has seeded itself in the perilymph or endolymph, which are the fluids inside the inner ear.
Oh, no.
Over the first 2 years of life, the virus slowly replicates, setting off localized inflammation that damages the tiny hair cells responsible for converting sound waves into electrical signals for the brain.
Wow, so it just creeps up on them.
It does. The hearing loss can progress from mild to profound, often destroying hearing in one ear before moving to the other.
And because this happens during the absolute most critical window for language learning, it can completely derail a child's speech and social development.
Exactly. A parent might not know anything is wrong until the child starts missing developmental milestones, not startling at loud noises, or failing to say their first words by age 1.
Which brings us to the obvious clinical question. How do we fight back? What is our arsenal if things go wrong?
The treatment landscape is highly specialized. For severe cases, especially in those transplant and HIV patients, the gold standard antiviral is an intravenous drug called ganciclovir.
Ganciclovir, okay.
We also use valganciclovir, which is an oral prodrug version of the same medication.
What is that one used for mostly?
Valganciclovir is specifically used to try and improve hearing and developmental outcomes in babies born with symptomatic congenital CMV.
Got it. And if those don't work?
If those frontline drugs fail, doctors turn to second-line options like cidofovir and foscarnet.
Let's focus on ganciclover for a second, because the mechanism of this drug is just fascinating.
Wait, if ganciclover is what you call a nucleoside analog, meaning it's technically inactive when it enters the body, how does it actually know to attack the virus instead of my healthy cells?
This is a brilliant piece of pharmacology. Ganciclover floating through a healthy bloodstream does very little. It requires a specific enzyme to activate it.
Oh.
The genius of the drug is that the activating enzyme is a kinase called UL97, which is produced solely by the CMV virus itself.
Wait, so the virus's own machinery is what activates the drug?
Exactly. Once the virus activates the drug, the ganciclover disguises itself as a building block for DNA. The virus incorporates the drug into its growing viral DNA chain, which immediately halts viral DNA synthesis and stops replication in its tracks.
That is brilliant. We were essentially handing the virus a loaded weapon and tricking it into pulling the trigger on its own replication.
Exactly. It's a Trojan horse.
But I imagine these treatments are not without their risks. Unfortunately, no. The dark side of this treatment is severe toxicity. Ganciclover is notorious for causing bone marrow suppression.
Meaning what exactly?
Leading to massive drops in white blood cells and platelets. Remember, you are giving a highly toxic drug to a patient whose immune system is already compromised or actively being suppressed.
Right, like the transplant patient. That's a brutal catch-22.
It is. And on top of that, the virus is highly adaptable.
This is where we run into the threat of resistance, right? If a patient fails to respond after 14 days of appropriately dosed antiviral therapy, what is happening on a microscopic level?
The virus realizes the trap. It mutates the shape of its UL97 kinase or its DNA polymerase so the drugs no longer fit or function.
Oh, wow.
Yeah. When we're looking at refractory or resistant CMV, the medical options shrink dramatically and the mortality rate skyrockets.
Oh, we have incredibly toxic treatments and a virus with a 200-page blueprint that knows exactly how to outsmart them. Why don't we just vaccinate against it? We have vaccines for measles, polio, COVID. What is the holdup with the CMV vaccine?
Developing a vaccine for CMV has been considered a top-tier public health priority for decades, but it is incredibly difficult. Currently, there is no vaccine available. Nothing approved yet. In a healthy person, natural immunity relies heavily on cytotoxic CD8 and CD4 T cells. They're the immune system's special forces keeping the latent virus in check.
Right.
We also produce antibodies that target the virus's surface glycoproteins, specifically proteins called GM and GB, to stop it from entering new cells.
But the virus doesn't just sit there, does it? It wages active warfare against those very defenses.
It does. Those 200 genes we talked about aren't just for building the viral structure. Many of them encode specific proteins designed solely to sabotage the host's immune defenses.
For example,
it interferes with class I and class TOI HLA presentation.
Hold on, let's translate that for the listener. What is HLA presentation and how is the virus stopping it?
HLA presentation is essentially a cellular alarm system. When a healthy cell is infected by a virus, it chops up a piece of the virus, attaches it to an HLA molecule, and displays it on its outer surface.
Like a warning sign.
Yes. It's waving a chemical red flag, telling the passing immune system, I'm infected, destroy me.
Right.
CMV produces proteins that grab those HLA molecules and pull them back inside the cell or destroy them entirely.
So it cuts the communication lines. The infected cell looks completely normal from the outside.
Exactly. The immune system swims right past it. The virus also produces fake proteins that trick our natural killer cells into ignoring the infection. It literally blinds and confuses the host's defenses.
If we can't vaccinate against it and it actively sabotages our immune system from the inside, our only real defense is keeping it out in the first place.
That's right.
How do we prevent an infection that is carried by over 80% of the population?
On an individual level, especially if you are pregnant or immunocompromised, prevention comes down to meticulous personal hygiene.
Okay, what does that look like daily?
Well, knowing that toddlers are the primary innocent vectors, you must avoid sharing food, utensils, cups, or pacifiers with young children. If a toddler puts a pacifier in their mouth, it does not go in yours.
Note taken.
And you must wash your hands thoroughly with soap and water after changing diapers or helping a child use the toilet. The virus can survive temporarily on hands and surfaces, so mechanical scrubbing with soap is your best line of defense.
And what about on the clinical side? How are hospitals keeping vulnerable transplant wards safe from a virus that might be hiding in the donor organ itself?
In the healthcare setting, infection control is a high-tech surveillance operation. Hospitals don't wait for symptoms to appear.
Proactive then?
Very. They rely on rigorous preemptive monitoring using quantitative CMV, DNA, PCR testing, and pp65 antigenemia assays.
Now, PCR, we know from COVID, it searches for the viral genetics in the blood. What is the pp65 assay looking for?
The pp65 assay looks for a specific structural viral protein inside the patient's circulating white blood cells. By testing the blood of high-risk patients weekly, doctors can spot the very early signs of viral replication long before the patient develops any clinical symptoms, like the ulcers or the pneumonitis.
Catching it while it's small.
Yes. If they see the viral load ticking up in the blood, they immediately initiate preemptive antiviral therapy striking the virus, while it is still just a numbers game in the bloodstream.
So bringing this all together, where are we now in the global fight against cytomegalovirus?
We are in a state of managed endurance, I'd say. CMV is an ongoing endemic reality. We have highly sensitive testing that allows us to track the virus, but we possess no tool to eradicate it from the body.
Right.
In the clinical setting, managing CMV is a massive high-stakes balancing act. Doctors in transplant wards are constantly walking a tightrope.
Giving a patient just enough immunosuppression to prevent their body from rejecting a new organ, but not so much that they invite a deadly viral reactivation.
Exactly. It's a daily war of attrition in ICUs around the world.
So looking ahead, what does the future hold? Are we gaining ground, or is the virus adapting faster than our interventions?
The future holds significant hurdles. The rise of antiviral resistance is a major concern. Researchers are desperately working on new classes of drugs that target entirely different parts of the viral replication cycle to overcome these mutations.
And what about the kids?
On the pediatric side, we are still facing the tragedy of late-onset hearing loss. Because the vast majority of babies are completely asymptomatic at birth, they are not routinely tested for congenital CMV in most hospitals.
That's so frustrating.
It is. By the time the hearing loss is finally noticed at age 1 or 2, the critical window for early antiviral intervention with valganciclovir has completely closed. Those children fall right through the cracks of early detection.
That brings us to a really provocative reflection for you, the listener. We started this deep dive by calling CMV a master of disguise. And the profound truth is, in a world where over 80% of us are already carrying this sleeping giant, this 200-page genetic blueprint, the line between being a healthy, asymptomatic carrier and becoming a vulnerable victim isn't based on avoiding the virus.
You likely can't avoid it.
The only thing standing between you and the devastating tissue necrosis, the owl's eye cells, the blindness, is the fragile health of your own immune system. You are already the host. Your immune system is simply keeping the beast asleep.
It is a sobering biological reality. Our health is a constant dynamic equilibrium, and CMV is the perfect reminder of just how hard our immune cells are working every single minute of every single day to maintain that delicate balance.
Keep your immune system strong and wash your hands after handling those juice boxes. Stay informed. Stay prepared.
This has been Outbreak Brief.